Hello and welcome back to another video. Today I'm going to be reviewing SilverStone's latest small form factor chassis, the Sugo 15. Hopefully you've seen the build guide I've put together in this case. You'll find a link to it in the description if you haven't. So what I'm going to do today, I'm going to give you a run through the case features. I'm going to share the results of my thermal testing, and I have tested 14 different configurations in this case using a mixture of air coolers and AIOs. And then I'm going to be comparing it to some of the other small form factor cases I've built in the past. So I can tell you, should you get this or should you go with something else? So I think the first thing to get out of the way is to compare the Sugo 15 with the Sugo 14. Now both these cases are exactly the same size, and the big difference between the two of them is the Sugo 15 is the more premium of the two. And being the more premium of the two, it has a very premium price point. In the UK at the moment, you can pick up this case for just under £160, while you can actually pick up the Sugo 14 for about half that price at just under £80. So what does an extra £80 get you? Well, the main thing it gets you is on the outside. The panels on the Sugo 15 are made from aluminium, while on the Sugo 14 they're made from steel on these four sides and at the bottom, while at the front it's a plastic panel. The other main difference is with the front I/O. The Sugo 15 and Sugo 14 both share two USB Type A 3.0 ports, but the Sugo 15 also has a Type C port, whereas the Sugo 14 has an additional Type A port at USB 2.0 speed. So whether those additional features are worth double the price, I'll have to let you make your own mind up on that. I've only got the Sugo 15, so that's what I'm going to focus my review on. So the Sugo 15 comes in two colours, black and silver. It's just over 19 litres in size and weighs in at 4.25 kilos. So I think one of the features that makes this case stand out is the fact that it can be used in two different orientations. So in the orientation I have it at the moment is very much the traditional orientation. The motherboard is at the back of the case. The graphics card is in a traditional horizontal position. You can actually rotate the case round. Having the motherboard on the back, the graphics card will now be at the front of the case in a vertical orientation. So one of the nice things about this is you're actually able to get a vertical GPU without using a riser cable. Your GPU plugs directly into the motherboard. And anyone who's trying to use new Gen 4 technology with existing riser cables will know that that's fraught with problems. So a nice option to have. So because of the option to have the case in two different orientations, SilverStone shipped the case without the feet applied. You will find feet of two different lengths in the accessory bag, so once you've decided which orientation you want to go with, you can apply them to the case. So looking at the front I/O, we've already mentioned the two USB Type A and one USB Type C ports. As well as that, you've got a power and reset switch, a combined headphone and microphone jack, and a hard drive indicator LED. So another nice feature of this case is that the aluminium panels on both the top and the bottom and both sides are fully removable. Each panel is held on with two captive thumb screws at the back. Once they have been loosened, the panels can simply be slid backwards and removed. With all four panels off, you've great access to the case, which makes building very straightforward. All three of the panels with perforations have magnetically attached nylon dust filters. Another nice feature that's obvious once you've got the panels off is that you have a really large cutout at the back of the motherboard. So that's going to mean mounting M.2 SSDs or changing the motherboard backplate if you want to mount a cooler once the motherboard's installed should be fairly straightforward, which isn't something you can say about all mini-ITX cases. So although this is a small case, you can actually fit an awful lot of hardware in it. So from a motherboard point of view, it supports mini-DTX and mini-ITX motherboards. One thing that will probably surprise you given the size of the case is it's actually designed to be used with full-size ATX power supplies, although SilverStone do recommend sticking to a power supply with a length under 150mm. So I do think this is one area you're going to have to be particularly careful when deciding on the components you want to use in this case. The area directly behind the power supply is going to be where a lot of your cables are going to pass through, and actually where you're going to keep a lot of the cables so they're out of the way in the rest of the case. I used a power supply that had a length of 150mm, and I had no trouble at all with cable management. Although had you used one that was 10mm longer, I think you might actually have struggled with cable management. So I think one of the big reasons I didn't have trouble with cable management in this case is that I used SilverStone's optional short flexible cable pack, which is designed to be used with their fully modular power supplies. Obviously with a full-sized ATX power supply, it's going to come with fairly long cables and much longer than you're going to need in a case of this size. And this optional cable pack is reasonably priced, and I think it's probably worth the money in such a small build because the excess cable is going to be fairly tricky to keep out of the way. So the case will accommodate fairly large graphics cards. It has 3 dedicated slots, and as we've mentioned, depending on the orientation you've got the case in, your graphics card's either going to be in a vertical or a horizontal position. And the case comes with a built-in GPU support bracket. The maximum length of graphics card supported is 330mm and a maximum width of 148mm. The case has a removable bracket on the top on which you can mount a variety of things. So it will support radiators up to a maximum length of 240mm. Alternatively, you can fit either 2 140mm or 2 120mm fans. Or if you prefer, you can actually mount 2 3.5-inch drives on this bracket. Importantly, if you do mount 3.5-inch drives in this bracket, your cooling options in this case are going to be significantly limited. At the rear of the case, you'll find a single 120mm fan without any RGB on it. You do have the option, of course, to remove this and mount a 140mm fan at the back if you prefer. The only other fan mounting location is on the side of the case, and it will only accommodate a 120mm fan. Again, the options you choose with your CPU cooler will significantly affect whether you can actually use any of the fan mounting locations in the case. Another really important thing to keep in mind if you're going to use an AIO in this case is that the pump height needs to be less than 55mm. So I went for a Cooler Master ML240 mirror AIO for my build, and with the pump mounted to the motherboard and the radiator and fans mounted to the removable bracket, I couldn't actually rotate the removable bracket into the case because the fan on the left hand side was catching on the pump. Removing the left fan from the radiator, I was then able to rotate the bracket into the case and then re-secure the fan to the radiator using the thumb screws included. If I had a different AIO that didn't have thumb screws and I was having to use a screwdriver to screw them in, I might have had much more trouble. I did also try the Pure Loop and the Permafrost AIOs, and both of these fitted without any trouble. So just be careful, look at the pump height when you're deciding which AIO to go with. Looking at air cooling, the case will support CPU coolers up to a maximum height of 182mm. So when I did my thermal testing, I did manage to fit a Noctua NHD15 into the case, which has a height of 165mm, and I was pleased to be able to fit both of the fans on the heatsink. While height wasn't an issue, the width of the heatsink and the width of the fans was a problem. With the NHD15 mounted, I wasn't able to fit the radiator stroke fan bracket at the top. It caught on the heatsink, even with the fans all the way down. What was even more of a problem was that I was only just about able to get the top panel back on, and the heatsink was putting a little bit of pressure on the top panel. So in mounting such a big cooler, you were giving up 2 of your case fan locations. So as if this wasn't bad enough, in your 2 remaining case fan locations at the rear and at the side of the case, you were no longer able to fit a standard thickness 120mm fan. Importantly though, you could fit some slim Noctua fans which are 15mm thick, both behind the heatsink and in front of the heatsink. Again, it's important to mention the slim fans do have limitations. They are less powerful when it comes to airflow compared to the standard thickness fans, and they also bring additional noise. So looking at the drive mounting locations, as we've already mentioned, the only place for a 3.5-inch drive is on that removable radiator stroke fan bracket, which I think wouldn't be a great idea. The case will accommodate up to 3 2.5-inch drives on dedicated mounts. There's one of them in the main compartment of the case, while if you remove the front panel, it's held on with 2 screws, and once they're removed, you can simply pull it away. You'll find an additional 2 mounts at the front of the case. Okay, so that's all the case features. Let's take a look at the build I put together in the case. Okay, so this brings us on to the thermals. In case you haven't seen my build video, I'll give you a recap on the components in the case. So we had a Ryzen 7 3700X being cooled with a 240mm AIO on the top set to intake. Rather than use the stock AIO fans, I was using some Noctua fans optimised for static pressure on the radiator. At the rear of the case, we had another 120mm Noctua fan optimised for airflow. And then for the graphics card, we had the Strix 3080. Looking at the temperatures, both the CPU and the GPU idled at 35 degrees, while under a 30-minute stability test, the CPU reached a maximum temperature of 97 degrees and the GPU a maximum temperature of 73 degrees. And having used both the CPU and GPU in a variety of other builds, these temperatures were a little bit hot, both at idle and under load. So I wasn't actually that surprised by the temperatures for a number of reasons. Firstly, the AIO, the fan on the right of it, is very close to the power supply, so there's not an awful lot of room for airflow on that side of the radiator. The other thing, we had fitted a massive graphics card in a very small case, so again, it's a fairly hot graphics card and there's not a lot of room around it for airflow. What did, however, surprise me was the idle noise at 30 decibels. This is incredibly quiet for any PC build, let alone a mini-ITX build, and in fact was equal with the quietest PC I have ever built. The noise did, however, ramp up under load conditions as expected to 49 decibels, but was still pretty reasonable looking at my other mini-ITX builds, which I'll share with you later in the video. So the first question I wanted to answer was, were the thermals better with the GPU in a vertical or a horizontal orientation? So I simply rotated the case around 90 degrees so the GPU was now in a horizontal orientation. So that did have an adverse effect on temperatures. CPU temperatures increased by 1 degree at idle and 3 degrees under load. There was no difference to the GPU temperatures at idle, but the GPU temperatures increased also by 1 degree under load, and there was no difference to the noise levels between the builds. Looking at the results, it seems having the graphics card in the vertical position works better when it comes to thermals, so for the rest of the thermal testing configurations using these particular components, I kept the graphics card in that orientation. The next thing I want to look at was, did adding a second exhaust fan to the side of the case improve temperatures? Adding the second exhaust fan wasn't without problems because the tubes on the AIO did extend over to where the exhaust fan would go. So the only way I could get the second exhaust fan in was to use a cable tie on the tubes in the AIO, keeping them in towards the back of the case and out of the way of the exhaust fan. So with the second exhaust fan in, CPU temperatures at idle went up by 2 degrees, but GPU temperatures came down by 4 degrees. CPU temperatures under load came down by 1 degree, and GPU temperatures down by 2 degrees. The second exhaust fan was associated by 1 decibel of extra noise, both at idle and under load. So I think weighing everything up, it seems that adding a second exhaust fan in at the front is a good idea. The next thing I wanted to test was how good was the stock SilverStone fan that came with the case. So going back to my original configuration, all I did was replace the rear Noctua fan with the stock SilverStone fan. So looking at the temperatures at idle, the CPU was 2 degrees hotter while the GPU was 2 degrees lower. Under load, there was no difference to the CPU temperatures while the GPU temperatures came down by 1 degree, and there was no difference to the noise levels both at idle and under load. So I think looking at these results, we can say that the SilverStone fan included with the case is of good quality and there's no reason at all to change it out for something else. The next thing I wanted to test was, because we had pretty good noise levels but thermals could do with a bit of improvement, was if I used the original fans on the AIO, would that improve the thermals? In previous builds, I have found that it did improve thermals but resulted in significantly more noise, which was the reason I had opted for the Noctua fans in my original build. So putting the stock Cooler Master Sickle Flow fans back on the AIO, the CPU temperatures came down by 1 degree, both at idle and under load. GPU temperatures at idle went up by 2 degrees, and there was no difference to the GPU temperatures under load. Noise-wise, there was no difference to the temperatures at idle, but the noise levels under load came down by 1 decibel. So unlike in my previous builds with this AIO, adding the Noctua fans didn't really seem to add any advantage, and when you consider it's going to come at extra cost, it doesn't seem like a good idea. The next thing I wanted to look at would replacing the large hot 3080 Strix with a 2070 Super result in an improvement in temperatures, because I did have some concerns that using such a large hot graphics card, which basically occupied the whole of that compartment, would affect airflow in the case. So I didn't get quite as big a difference as I was expecting. At idle there was no difference to the CPU temperatures, while GPU temperatures came down by 4 degrees. Under load, both CPU and GPU temperatures only came down by 1 degree. Where we did, however, notice a big difference was in the noise levels. While the idle noise went up by 2 decibels, the noise under load decreased significantly to 42 decibels. And to put things into context, the quietest PC that I have built so far had an average noise level of 40 decibels under the IDA64 stability test. So given that we have got a mini-ITX system producing similar noise levels is fairly impressive. The next thing I wanted to do was to have a look at air cooling, so I went ahead and installed the Noctua NHD15 in the case. As I've already mentioned, we were unable to fit the radiator bracket above the cooler, so that meant there was no fans mounted there, but I was able to fit a slim fan both in front and behind the heatsink. So this was one test I almost didn't run because I was concerned about where the intake was going to come at the front and how close the front fan on the heatsink was to a solid panel. But I was glad I did run it, because when we looked solely at the temperatures, the air cooler did outperform our best configuration with an AIO so far. So all the temperatures of both the CPU and the GPU at both idle and under load came down by 1 degree compared to our recording with the 240mm AIO. Unfortunately, this did come at a cost, and that cost was noise. So there was an extra 8 decibels of noise at idle and an extra 2 decibels of noise under load. So based on the very small improvement in temperatures but the massive increase in idle noise, this wouldn't be a configuration that I can recommend using. The next thing I wanted to do was to try and work out, was the noise coming from the slim fans that we had added both in front and behind the heatsink. So I started to remove them one at a time and look and see what difference it made in temperatures and noise. So the first one I removed was the slim fan at the front, leaving just the slim fan behind the heatsink. So without that slim fan at the front set to intake, the CPU temperature at idle increased by 4 degrees, while under load it increased by 1 degree. Looking at the GPU temperatures, they increased by 2 degrees at idle, but actually came down by 1 degree under load. Noise level wise, removing one of the slim fans brought the idle noise down by 1 decibel, but made no difference to the noise under load. Next I went ahead and removed the second slim fan, which was acting as an exhaust at the rear of the case, so that left just the NHD15 in the case without any case fans. This resulted in a further 1 degree increase in both CPU and GPU temperatures at idle, whereas under load the temperatures of both the CPU and GPU increased by 3 degrees. There was no further reduction in the idle noise level, whereas the noise level under load came down by 1 decibel. So what this results tell me is that it's actually the NHD15 itself that is responsible for the high idle noise, and that the case fans themselves do a great job of improving the temperatures. And if you are going to want to use something like an NHD15 in this case, you would want to use slim fans both at the front and at the rear. So I was keen to test a slightly smaller cooler that would allow us to use the top radiator bracket. So I went ahead and fitted the Be Quiet Dark Rock TF in the case. With this I was able to fit a standard size case fan both in front of the cooler set to intake, and also one at the top of the case over to the right hand side also set to intake. I wasn't however able to fit even a slim fan above the cooler or at the rear of the case as an exhaust. So looking at the temperatures here and comparing them to those that we got with the NHD15, at idle CPU temperatures were 4 degrees hotter while GPU temperatures were 3 degrees hotter. Under load, both CPU and GPU temperatures were a whopping 9 degrees hotter. Where the cooler was slightly better was when it came to noise levels, and it was associated with 8 decibels less noise at idle and 2 decibels less noise under load. So while the improvement in noise levels was nice, the fact that that came at such a massive increase in temperatures meant that I couldn't recommend this configuration at all. So before I went ahead and told you whatever you do, don't use this cooler in this case, I had to run one more thermal configuration, and that was flipping the top intake fan round to exhaust. So doing this, both CPU and GPU temperatures came down by 1 degree at idle. There was no difference to the CPU temperature under load. However, the graphics card temperatures went up by 3 degrees under load, and there was no difference to the noise levels, both at idle or under load. Okay, so I think I can now go ahead and say whatever you do, don't use this cooler in this case. So at this stage, I had actually finished my thermal testing. And while I was incredibly impressed with the noise levels the case offered, the temperatures I was less so impressed. But given the fact that the AIDA64 stability test is a really extreme test, under normal day-to-day use, the actual temperatures are going to be significantly lower. Under gaming, I generally find the CPU temperature is at least 10 degrees lower, and in some circumstances 20 degrees lower. The GPU temperatures are often very similar or slightly increased during gaming. So bringing those temperatures down with excellent noise levels, I was actually fairly happy with this case, and I decided to move my secondary system into the case. I did make a slight change to the CPU cooler, and I went for the PureLoop 240. The reason for that is whatever way I seemed to be able to get it fitted in, I had no issues with the cables catching in the front fan, and that was going to be important to add the front fan, and I didn't really want to have to use a cable tie on the tubes. The other change that I made was I changed the case into this current orientation, which is the graphics card in a horizontal orientation. And I thought to myself, after I'd done the build, I may as well run the thermal test one more time, just out of interest to see how the PureLoop performs. So when I ran the results, I got quite a surprise. CPU temperatures at idle came down by 3 degrees, while under load it had come down by 5 degrees. GPU temperatures had increased by 1 degree, both at idle and under load, whereas noise levels had improved by an extra 1 decibel. So I got a massive improvement in CPU temperatures, some further improvement in the noise levels, and only a very minor increase in GPU temperatures, which actually were already pretty good. But importantly, I had changed 2 variables. I had changed both the CPU cooler, and as well I had changed the orientation in the case. And at this stage I was kicking myself. I had done the original test with the GPU in the horizontal and vertical orientation, but that was a massive GPU that had basically obstructed airflow throughout the whole of the case. And the 2070 Super was so much smaller and wouldn't in any way restrict airflow and would also make a lot less heat. So I needed to run one more test to try and determine, was it actually the change in the CPU cooler, or was it change in the orientation of the case that had brought the CPU temperatures down. So all I simply did was flip the case around 90 degrees and run the same testing again. So with the GPU in the vertical orientation, both at idle and under load, the CPU temperatures increased by 1 degree, while the GPU temperatures came down by 1 degree. Having the GPU in the vertical orientation was however associated with more noise by 2 decibels at idle and 1 decibel under load. So what this test tells me, with a smaller GPU, you're going to get better CPU temperatures with the GPU in a horizontal orientation, while you get better GPU temperatures with the GPU in a vertical orientation. But importantly, you get less noise also with the graphics card in the horizontal orientation. So weighing all that up, the horizontal orientation would now be what I would recommend for a smaller graphics card, which is the opposite to what we find with the larger graphics card. The second thing this tells me is that the PureLoop 240 is an excellent cooler to use in this case. It gives significantly better temperatures over the Cooler Master AIO. Importantly, it wasn't the PureLoop at stock. I had replaced the stock fans, which I had found to be incredibly noisy previously, with the Noctius fans optimized for static pressure. So that combination seemed to work very well, and that's what I'm going to continue to use in my own personal system. So I'm going to put a summary slide up of all 14 of the thermal configurations that I have tested. So you want to have a closer look at these, go ahead and pause your video. So what I want to do now is compare my results from this case with some of the other mini-ITX cases I've built in the past. So what you'll see on the screen is the best results from each of the cases whenever I did my detailed thermal testing. So the first thing you'll notice looking at that table is there's 2 results for the NR200P. The first one was the best configuration that I think you should build. The second one was the best configuration when it came to noise levels, and in fact it was the only one that gave me acceptable noise levels to my ear. The big problem with that was the only way you could do that was to have the radiator at the bottom as an intake, and that meant the pump was up above the radiator, which was a configuration you should not build. So for the purposes of this comparison, I'm only going to be comparing the first result in the NR200P. So the first thing I want to do is look at the noise levels. So we look at the idle noise level of 32 with our build. That is significantly better than any of the other mini-ITX builds. And if we look at the Pyramid Mini 806, it was all the way up at 41. And interestingly, 41 decibels was actually what our system in this build reached under full load. Looking at the noise levels under full load, again, this system was the clear winner at 41 decibels. And if we look there at the NR200P, all the way up at 54 decibels, which was the main problem I had with this case. Looking at the temperatures, there was a big difference between the Sugo 15 and the NR200P compared to the TE150 and the Pyramid Mini 806. And that's because the latter two cases, the maximum size of radiator that you could fit in them was 120mm. Comparing the Sugo 15 to the NR200P, CPU temperatures were better both in idle and under load by 2 degrees. There was a much wider gap when it came to GPU temperatures, with GPU temperatures being better by 3 degrees at idle and 8 degrees under load. It was the opposite story when it came to noise levels, with noise levels in the Sugo 15 being lower by 8 decibels at idle and a whopping 13 decibels under load. And in case you're wondering, I think the big reason for the improvement in GPU temperatures in the NR200P was the ability to have two slim fans at the bottom set to intake below the GPU. When I tested the same case without those two slim fans, the GPU temperatures and as well the CPU temperatures came up significantly. So now we've reached the stage in this review where I need to tell you, should you go out and buy this case? And I think this case has a lot of advantages. I think it's a good looking case, particularly in this orientation where you've got the graphics card in a horizontal position. I wasn't so fussed on the look of it where you had the longer side sitting on its back and the graphics card in a vertical orientation, but I think this way round, to me, it looks good. We've actually now got pretty reasonable temperatures in it, and remember the IDA64 stability test is an extreme test and the CPU temperatures are likely to be around about 15 degrees lower than that during gaming and as much as 20 degrees lower. So we've got reasonable temperatures, but the one place we have got exceptional values is the noise levels. This is an incredibly quiet case, and if noise levels are something that's really important to you, I can strongly recommend this case. The other things, this is a fairly easy case to build in with all the panels off. The TU150 from Lian Li, while it's a good looking case, it was an absolute nightmare to build in. From routing cables was incredibly difficult, and then you had no access to the rear of the motherboard should you wanted to change your CPU cooler or change your M.2 SSD. So this case has all those advantages. The other nice thing I think about this case is the fact that you can use full-size ATX power supplies, although there is a length limitation on them. Particularly with SFX power supplies being significantly more expensive, that is going to be another advantage to this case. I think maybe the only downside to this case would be its price. And in fact, the Sugo 14, although I haven't actually seen it in front of me, at half the price is probably going to be the better deal. Whether the extra features that this case offers for double the price are worth it to you, that's going to depend on your own individual preferences. But summing everything up, yes, I can strongly recommend the Sugo 15. While you will get better temperatures in another case, I think you're really going to struggle to find better noise levels, and I think it's a reasonably good looking case as well. So much so that I have moved my secondary system into this case, and that's what I'm planning on using for the foreseeable future. So hopefully you find this video useful. If you have, remember to like and subscribe, and I'll see you in the next video.